Hey everybody, so got a few videos for you. This one that you're watching right now, I'm going to go through some of the problems on the review assignment, the review for the test tomorrow. Um, Combination of questions that I'll be finishing up that I did during class on Monday, and then also a few questions that were requested by you, you or your classmates. So here we go. All right, hopefully you can see this. Let's see, this first one is one that I finished up. I started when I went over this during class. Given a graph like this and I want to find all of the zeros, the exact values is kind of code for you might have to use the quadratic formula if you're not able to factor. Once I send it through synthetic division, I've got this reduced polynomial x squared minus 8x minus 2. So I send that through the quadratic formula. Again, this one asked for exact values. So the fact that I got square root of, this must have been the square root of 72. I have factored out the square root of 36. The square root of 36 is 6. And then 8 divided by 2 is 4. 6 divided by 2 is 3. And so I end up with 4 plus or minus 3 times the square root of 2. So when I'm listing the zeros, don't forget to list the one that we found just by looking at the graph, and the other two zeros I found with the quadratic formula. And then check and make sure that those make sense. Those are places where it's crossing the x-axis. Number two, also similar in that we're first going to look at the graph and find two places where it crosses the axis, just visually looking at it. When we send it through synthetic division, we'll verify that these work. Send it through once. We go from, this must have been from a 4th degree polynomial to a 3rd degree polynomial, and I've got another spot that I can recognize by looking at it. And so I send it through one more time using 1 the synthetic division process, and it's all the way down reduced to a 2nd degree polynomial. So worst case scenario, we have to do the quadratic formula. Best case scenario, it is factorable. Or maybe even this is a better case where we could just look at this and say, well, if x squared plus 1 is 0, x squared is negative 1, which means we're looking at I, plus or minus I in this case. And we can get that, I've got it written in factored form here. If you can't make the leap to do that, you could always send it through quadratic formula. If you can recognize that, you'll be in better shape. I'm just going to pause and make sure that this is recording. Okay, it looks like I am. Sorry, I just don't want to go through this process twice. Let's see, number 3, that's one that we did in class. A whole bunch of factoring. I'll maybe just talk about some of these. Question number 4 looks like one that I would probably do using the box method because there's a lot of ways of getting 6. I might guess and check once or twice, but not going to spend too much time. Question number 6, this sure looks like a factoring by grouping question. You've got 4 terms, and I noticed that the ratio of 2 to 3 is the same as the ratio from -8 to -12. And by the way, for those of these that I'm just kind of talking about, the answer key will be published by the time you're watching this video. Number 7, I would factor out at least an x squared. I would look at 147 and see if any factors of 12 could come out of that also. And in fact, 3 is a factor of 147. So I would factor out a 3x squared. And after you've got that factored out, the stuff that you're left with will be 2nd degree. You should be able to factor that. Same thing with number 8. First factor out that x, and then you've got a quadratic equation. You could factor using either the box method or guessing and checking. Number 9, if it's in this factored form, we can recognize zeros really easily. X plus 4 as a factor means -4 is a 0. X minus 6 as a factor means 6 is a 0. And then given the zeros, the vertex is halfway in between. So the average of -4 and 6 is 1. Plug 1 into the function to find is at -25. As I have done here, if you change your scale, make sure you are showing that on the graph, especially if your vertical scale is different from your horizontal scale. Number 10, I discussed it in class, but I didn't actually do it. This one is in the transformed form, so I can see that -5 is the value of the x-coordinate of my 0, and then that plus 32 moves the vertex up 32 spots. So I found the vertex first. And then the zeros I found, as you can see, just by solving the equation. Set it equal to 0, solve for x, you get a couple different values, -5 plus or minus -4, or sorry, -5 plus or minus 4, which I suppose is the same as -5 plus or minus -4. We get the two values of the zeros, then here again, draw your graph, and you're good to go. Quadratic formula, a few examples of this one. Question number 11, you have to get it into standard form first. Move everything over to one side of the equation. So you can identify A, B, and C. Plug them into the formula. Nothing too crazy here, but I've got a -24. And so I said that square root of 4 is 2, the square root of -1 is I, and the square root of 6, well, doesn't have any perfect square factors. So I leave that in the radical, take the other 2 out. And then, because 6 divided by 6 is 1, and 2 divided by 6 is 1/3, this reduces to the form that I've got here. If you have a complex answer, an answer with an imaginary component, I want to see it split up into real plus or minus the imaginary part. For something like number 12, where when you send it through, the square root of 41 doesn't have any perfect square factors, it's positive. If you left something like this in this form, I would be okay with that. If you want to separate it like I've done here, it's obviously okay also. The only time that I am going to penalize for not separating it into two terms is if you got the imaginary part, or hypothetically, in a case where the fraction reduces. If instead of 3/4, if this was like 4/2 and it was just 2, well, then you should simplify that fraction just like always. And number 13, I don't think there's anything too unusual about that one. Once again, the square root of 24 reduces or simplifies to 2i times the square root of 6, and then 4/8 is a half, 2/8 is a fourth, and so we end up with that as my simplified version. Let's see, anything else here? I guess I didn't do any of these from this section, but if you see a question like this one, if I give you this gigantic, scary 4th degree polynomial, we can factor this in this form. And if you send 7 through synthetic division, as we would do for this one, and maybe I'll just do this one quickly. Why not? If you don't want to see this, you can always skip ahead in the video. So sending this one through quickly, we get 3 times 7 is 21, -20 and 21 is 1, plus 7, -7 and 7, times 0, 2, and then 7 times 2 is 14. I don't know, did I goof up there? I don't think I goofed up there. I think I'm getting 28. So for this one, since I have a non-zero remainder, that just means that 7 is not a 0, which means x minus 7 is not a factor. So I would just stop this one because what I have left here can come out evenly. And so I really can't go any further with this one, which is a little bit of a shame. Let's take a look at one that we can go a little bit further with. Well, answers are in the answer key, and again, that is posted, but I guess I will say that if you are able to reduce it, you should be able to take the reduced form and then factor that one, either using just the box method, inspection, just looking at it and figuring it out, or of course, possibly doing factoring by grouping. I don't know, did I just say that? Well, factoring by grouping is definitely a possibility. Question number 18 and 19, where I give you a graph and say, what is the polynomial that makes this graph? I'm looking at the graph saying it crosses the axis at x equals 3, so x minus 3 would be a factor. It touches the axis at x equals -1, which means x plus 1 is a factor. Notice I've got the square there. It's twice that is a factor. And then the only other thing would be to look at the shape of the graph and say, since to the left it's going up to positive and to the right it's going down to negative, it means this must be a negative in front of it. And as far as what I will be looking for for penalizing or rewarding points on the test, well, we're doing pretty good there. If, however, we want to make it go through this 0.06, I would have to take a look at this and think, okay, when I plug in 0, we got 1 squared times -3 squared. So right now, as is, with just the negative in front of this thing, the value of the function at x equals 0 would be -3, and I want it to be +6. So I'll multiply -2 in front of this. Now -2 times 1 times -3 gives me that +6, and it goes in the right spot. Not as concerned about that, but in the interest of answering this question as accurately as I can, I will go with that. Question number 19 is going to be a little bit different. It looks like we're crossing at -4, so x plus 4. Looks like we're crossing at 0, so x minus 0. Looks like we're probably crossing at x equals 1/2. So actually, maybe instead of writing x minus a half, that's kind of a weird thing in a polynomial. Maybe I'll say 2x minus 1, because x equals 1/2 would make that equal to 0. And then x equals 5, and so we'll have x minus 5. I don't know if that page 3 of 4 gets in the way. Oh, it's kind of a pain. Anyway, there we go. This one says, please do not simplify, don't multiply it out, just leave it in factored form. This is the factored form that I'm talking about. If you want to expand it, exercise FOIL, go right ahead. And then finally, the dreaded word problem. Softball is thrown up with an initial velocity, blah, 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 blah. Well, here's the equation. Height of this softball as a function of time is given. They want me to find the maximum height of the ball. So my strategy is I'm going to use the quadratic formula. You can see that I've done that here. For something like this, I'm not worried about the exact answer. 32 squared minus 4 times -16 times 5 is, I don't know, some big number, but I just plugged it in my calculator because, frankly, in a context of a real world problem like this one, I don't care about the exact answer. And so these are the two values that I get from the quadratic formula. These are the two zeros. So we can see that the ball's going to land on the ground after a little more than 2 seconds. If I look for the maximum height, I know that's going to be halfway in between my two zeros. So add them together, divide by 2, find that equals 1 is the average of those two. So that's the time that it will be at the highest value. So plug that into my height function. When I plugged 1 into my height function, I got a maximum height of 21. And then I'll be honest, I got out my calculator and I plugged this equation into my calculator and I made sure that it was right. And in this case it was, so I felt pretty good about that. And that is the rest of that. So I will stop this one. Don't forget to check out the video. I've got one for Wednesday, introducing the new chapter. There is an assignment from that. And then also over the weekend, I've got another one. And you're hopefully not too upset by having homework over the weekend, but that's kind of the situation we're in. And it is a fairly simple section. You guys are going to be just fine with that section. But I'll stop talking about that and